Well, thank you very much. I've just really enjoyed this morning's keynote, and I think it's a great setup to talk about what's happening in Colorado and connect the dots between what you've already heard about investment and policy, the federal investment, as well as what the future technologies are. And what I'd like to share with you, and Peter will be joining me, is what we've been doing in Colorado over the last decade. A decade ago, we started the Colorado Energy Research Collaboratory. Do we have a clicker? Sorry. And we'd like to share with you what this group has done. So looking at it, there's been a state investment of $8 million. And that state investment, relatively modest, has been leveraged very significantly. And more importantly, what it's done is it's brought together Colorado State University, Colorado School of Mines, University of Colorado Boulder, and NREL. And you'll see that this has had a really powerful effect, that we've been able to do a number of things that we could never do individually. And so we'd like to share some of that. So this stimulated the partnership, and former Governor Bill Ritter really gets credit for helping to catalyze that and move that forward. We've had about a 24-to-1 return on investment. We feel like that's a very strong example of what a small investment can do, how we can leverage it and have greater impact for the state. And what's happened as a result of this over the last decade in building these relationships and building the outcomes is that we've really created a one-of-a-kind energy research and translation ecosystem. So kind of looking at more carefully, what are some of the outcomes before we go to specific examples? This unique partnership has really supported a lot of significant outcomes. There's been more than, I can barely see this, sorry. With that $8 million investment, we've had $96 million in externally funded energy research. So much of that coming from the federal government. So when you hear them talking about us leveraging it in the state, we've been able to leverage the state investment, the federal investment, and work with partners in the state. Additionally, there's been more than $200 million in local economic impact. So there was a study that we commissioned to look at what was the impact overall. So not only were we able to leverage those dollars, but we've had very significant economic impact. One of the things that we're really proud about is that there are about 90 plus new companies that have spun out of the research at our 4 institutions, and about 540 new technology licenses. So very different ways of getting our technology out into the state to have impact. The other thing is the ARPA-E is a very, very competitive way to fund what I would call more bridging the valley of death. So technologies that have had funding for research, and now you want to look at how to take them to a commercialization pathway. Colorado is number 3 in the country for ARPA-E grants. So that says a lot about the competitiveness of the work that is happening in Colorado. And in addition to this, with this orientation and coming together with the 4 research universities, we've had about $500 million invested among the 4 universities and NREL, in the facilities as well as strategic hires that's really leveraging us for the future. So it's really been an exciting development over the last decade. Peter.
Thank you, Terry. Good morning. So this morning's session thus far, I think, has provided a really good context for what I'm about to share with you. I think what's clear is that since the energy crisis of the 70s, innovation in the energy space has been enormous, have largely to do with the advent of solar and wind, and a range of other renewable resources like geothermal. In fact, that was also not just the beginning of the DOE, but the beginning of NREL in 1977. And in fact, it's interesting to note that the price of solar has dropped 99% since that point. Now, what I find notable here thus far is that since that crisis, when we were concerned about energy for the global population has doubled. The GDP has continued to increase, and over the next 2 decades, we anticipate the global GDP is going to increase by a factor of 2. And it's going to be mostly in these emerging economies. So we're thinking about, as Eric Thune pointed out, that non-OECD countries are now looking for a standard of living and will have a standard of living and demand one just like we do have in the more advanced nations. What it means then is that there are more challenges for energy. And it's not just LNG, there's water, and there's also materials, mining and new materials that have to be developed. So these systems are all connected. Now, with regard to energy, we're thinking about the new variable sources. Wind and solar is free. And we have a new grid system that has now got to connect these variable sources with the conventional sources. The original grid developed by Edison wasn't designed for what it does today. It was simply designed to simply generate power and dispatch. With the new variable sources, the point now we have to think about very new technologies that we can take advantage of it. So for example, there are, the utility companies are coming with smart inverters. Energy storage has become important. But even beyond that, customer needs, customer demands, so the Internet of Things. People now beginning to have rooftop solar. They can exchange, they can sell. All these sources are now distributed across the nation. And so now we need a grid that ultimately has to be able to operate in a way that becomes efficient for every single consumer. So this grid of the future, which is now going to have a range of distributed energy resources, all kinds of customer demands, will ultimately have to be autonomous, taking advantage of artificial intelligence and machine learning. This is where we're going. This is where all the Colorado universities, NREL, and all the places around the globe are actually very concerned about, or in fact thinking carefully about. Now, as we go forth, we worry about now energy management for consumers, how to make sure the grid operates in the way that it should. We think about energy efficiency. Manufacturing is a big thing. And so as we look at these large problems, Colorado, as many other states, but especially Colorado, can actually make a difference. And this is where the Collaboratory comes in. The Collaboratory, as Terry pointed out, is this nice collaboration between the main Colorado universities and NREL. And the idea is that what's happened so far, and shown very clearly, is that very small groups nucleate together and come up with ideas. So many of these initial ideas are not funded, and Collaboratory has a way of funding some of them. And what Terry pointed out to you is that as a result of this initial funding, these groups are able to compete for larger grants, tens of millions of dollars, and the economic impact. So what I'm about to do is to begin to give you some examples, very specific examples of the impact of the Collaboratory. So begin with the first one. So NREL, and paid for by DOE, EERE, developed this energy systems integration facility. And here's why it's important. A company or utility may develop a new energy technology. Utility, and this has happened, developed a smart inverter, and they like to test it. And they can't put it out there in the market to affect the customers, and so what they do is they bring it to a place like ESIF at NREL, and it's in an artificial environment to understand how this thing operates in a broader grid system. This provides insights before it's able to proceed. Now, this facility now is useful for many things. As one of the examples I showed you right now, there's a new ARPA-E grant between the Colorado schools and NREL. And one of the things you'd like to find out is that looking at building occupancy, so home or commercial buildings, and sensors to determine whether or not individuals occupy them or not. That will help to determine whether or not you need to use cooling or air conditioning and things like that. So that could reach enormous energy savings. ESIF is a lot more than that. I don't have time. I don't want to belabor it because it's an NREL specific thing. But the idea is that it's a way for you to think about future energy systems, our new energy technologies, and understand how they operate in an artificial environment before you can deploy them elsewhere. Places like Hawaii and other places are taking advantage of that. So it's real and it's quite significant. Other questions, materials, and devices. There was an early, I'd say, investment in a new class of materials called perovskites a long time ago. And by way of context, if you look at all the solar, it's mostly driven by crystalline silicon. Crystalline silicon solar cells, you need large billion-dollar fabs around the globe to make this work. The beautiful thing about this new class of materials, solar cells, is that they can actually be processed rather cheaply. In fact, if I gave somebody the recipe, you might be able to make some, literally. And one of the things that NREL has done, collaboration, is that it can actually produce these things almost roll to roll, almost like a newspaper. So not only can you actually make it cheap, really, really cheap compared to silicon, but it can be produced really, really rapidly. The efficiencies are comparable to that of silicon, and so there's a lot of research going on for the future. There's other research going on in buildings. For example, smart windows that are perovskite-based materials where sun shines, the window becomes very dark, and it behaves like a solar cell. And as it cools down, the window becomes very, very light. Very interesting physics. There's other work going out Boulder for actually looking at very passive cooling of a building without energy, sort of new material systems that work by radiative cooling. They absorb very little from the sun and are able to emit. And so those are good examples of the kinds of work that's going on in terms of solar cells and cooling and materials. Again, I'd say an initial investment by the Collaboratory led to much larger investments across the place. And in fact, because of that, if you look within Colorado, it's the best place in the US right now for research in the perovskite area. I won't name names specifically. Some of you sitting in the audience, I don't want to forget names, so I won't try. All right. Here's a biofuel. So here's what's exciting. We can show from just biomass, plant waste, plant residue, via a range of chemical or biological processes to create new chemicals and materials from biomass. One of the latest examples, paper published in Science since then, really gets back to this question of how do you do this? So one of the programs that we're talking about, a few programs, namely the National Biofuels Consortium right now, it was initially invested in by the Collaboratory. And the idea is how do you develop new materials and new fuels in this case from plant waste. And so the idea then is to actually make fuels for jet fuels or automobiles or what have you, and it's going to be blended with the petroleum-based fuels. It helps to meet some sort of sustainability standards. There's other work going, for example, on this new Center for Bioenergy Innovation. Kerry Eckert is from UC Boulder, is one of the leaders. It's a broader program led from Oak Ridge National Labs together with a whole range of other labs and universities. But in the case of the work going on here in Colorado, the work surrounds trying to identify new sort of organisms, microbial organisms, that help convert the lignin from these plants towards fuels, as an example. There's also later work going on in other areas that where this is also being done and accelerated. I mentioned here this new startup Inscripta from CU Boulder, again coming out of early investments in the Colorado Center for Biorefining and Biofuels. So this whole idea of biofuels and bioproducts is important. Idea is that you can make chemicals and materials from plant waste instead of going to petroleum. Two other examples I want to share with you, one of which is a renewable carbon fiber consortium. And here's the idea. Polyacrylonitrile, from which is fibers for carpets and a range of packaging and a range of things, sort of a commodity polymer, typically comes from petroleum. It's a very expensive process and major infrastructure with all kinds of environmental concerns, things giving off cyanide and what have you. It's been around forever and major investments. Recently, what's been shown is that you can actually make polyacrylonitrile from biomass, and it can be done even more cheaply. And so there's now a new way of getting carbon fibers from polyacrylonitrile, and that's in large part one of the examples that we've seen there. Let's go to wind energy. You guys, have any of you ever seen a wind blade being transported across the interstate highway? Yes. It's a mess, right? And so going forward, as we look about wind in the future, and if wind is going to provide the kinds of energy that it needs to in gigawatts or terawatts in the next 10 years or so, they're going to have to go to building larger and larger towers, wider and wider sort of wingspans. And so you can imagine to a point there, you cannot transport wings, sort of blades that are too long. So you're going to have to figure out a way to do this in a way that's on-site, this on-site manufacturing. And so, the idea then, the advanced composites manufacturing innovation, is to think of new innovative ways for this, to create wind blades. And so the new generation, potentially, if this works, is a collaboration between a lot of companies, DOE, a lot of universities, by and large, to manufacture blades for wind turbines using thermoplastics. And it's going to be done locally. And the idea is you can actually begin to think about making this out of plastics that are made from biomaterials instead of coming from petroleum. So there's a lot of excitement here, a lot of direction, a lot of new directions. And I think the last example is looking at methane, sort of natural gas being a big part of our lives in the future. And one of the challenges that people come across often is methane sort of leaks. And so one of the things that's happening is the Methane Emissions Technology Center is really has a lot of funding from ARPA-E to look to develop sensors. And in fact, some of the major advances coming out of CU Boiler from JILA, Nobel Prize winning work, provides new techniques and methods, mechanisms to be able to identify and sort of measure with great deal of precision extremely low amounts of methane that's coming from different environments. So I think that what I've done is I've given you a series of examples across the board, from wind to methane to solar, to give you, it's an exciting time. It's an innovative time. There's no shortage of ideas. And I think the main advantage of the Collaboratory is that we can tackle problems other places can't, in a sense that some of the university faculty have appointments of NREL as NREL staff members, so that they can take advantage, and some of the NREL staff members have university appointments, so they can take advantage of what we bring to the table to solve problems that we would never otherwise solve by ourselves, and do them in a very seamless way. And I think the minor investments and the outcomes from the Collaboratory give you a really good idea of the significant benefits to Colorado and to the nation.
So where do we go from here? I think Peter did a nice job of setting up examples of the things that have come out of the Collaboratory. And so we're at a point of where do we go from here? How do we basically take it to the next level? And that's what this is about establishing a national energy innovation technology scale-up hub. And it's leveraging what we've done from really fundamental research all the way through commercialization and helping this become the center for the nation for doing that. So being able to develop, do the fundamental science, develop the new technologies, translate it, and work with our partners to then scale it up. And that's really the next phase that we see for Colorado and for the Collaboratory. And we want to share this with you because we want you to be partners with us and moving in that direction. And if you look at what's unique about Colorado, the 3 research universities and what each have built up in the energy area, NREL being the national lab for renewable energy has been extremely valuable, and we've just catalyzed around that asset that we have. We have industries in the state that are really leading in this space. And also we have an opportunity to take the startup community that we have in the state of Colorado and use that to help scale up new technologies. So looking at some of our resources, so I just listed a number of resources here in terms of our scale-up ecosystem that currently exists in the state, as well as facilities that we have that are very unique, that are accessible not only to the universities, but also to others in the state. So finally, we have a real opportunity here in Colorado to take this strength. And I think this conference here, Symposium, helps us to kind of coalesce and bring everybody together, where we have our research that is really leading edge to the point where we're attracting ARPA-E to come here for the first time out of DC. Commercialization, we have a number of commercialization examples where we've taken these technologies and taken them out of the university, as well as showing applied approaches with our methane detection and evaluation center up at CSU. The economic and workforce development that we've seen, one of the things that we haven't mentioned that's been a really important piece of this is all of the students that have been funded through this research. So we have a huge number of graduate students and undergraduate students that are working in all of our labs. And that's a big key to our workforce development and our technology transfer, is those students that have gone through the program. And finally, partnerships have been really key. Working with industry and building these industry partnerships has been part of helping us to understand what are the problems that need to be solved and how do we solve those problems. So with that, I'd like to stop here, and if there's maybe one question we can entertain, anybody have a question that we could answer? Everyone's ready for lunch? Okay. So Peter, do you want to join me? So the Collaboratory would like to recognize Maury Dobby. Maury, why don't you please come up here? Maury has single-handedly put together this whole conference, and usually I'm used to teams working on this. Maury's a team in herself, so she's just done a fantastic job, and we wanted to recognize her, and please express your thanks for everything she's done to bring this together and put together an outstanding program. So thank you very much.